Hi, everyone. Professor Hosmer here. We're going to get started right away here. Welcome to CYBV 473, Violent Python, week 5. And this week, we're going to be processing some binary files, which is a little different than processing text files, especially if they happen to be, very large binary files that we need to break up into smaller pieces when we do those. So I am recording the session, so I'm going to mute everybody, and then you have the ability to unmute yourself. Can you guys, somebody send me a signal that you can hear me and see my screen? I think it should be all set, but just double checking.
There. Yep.
Great, thank you. Okay, got a little bit to cover tonight, so I'm going to go ahead and get right into it. Again, we're going to be talking about reading and processing binary files, kind of dumping the contents in hex, talk a little bit about regular expressions tonight because it'll be part of your assignment this week. So I'll kind of introduce what those are and how we actually use them to extract specific information from, again, binary files. They can be used on text files as well, but typically they're used when we're processing binary data. So the first thing I'll do is I'll quickly go over assignment 5 and 6, just so that if you had any questions about those. Sorry, I have lots of windows open on my computer. I apologize. Okay, back to let's see, week 4. I have so many files open here to do tonight. Okay, so this is a week 4 assignment number 5. And in this particular case, we were just going to scan a directory and then basically use the Python image library to determine if the file that we're opening is in fact an image or not. And if it is, we're going to collect some basic data about that particular image. So let me actually go ahead and step into this script and kind of walk through it for you. So we're importing a couple libraries. I mentioned we're using the Python image library here in order to do this basic function. I'm also going to bring in the second third-party library, which is the pretty table library. I typically set up whatever I'm going to put in the pretty table pretty much at the top of the file, and that basically is just creating a list that I'm passing to the pretty table function, creating an object called table, and then each of the fields that I want to fill in. So remember, when you're creating the table, that has to be a list, and they have to be separated by commas, and each item in the list needs to be a string, and it'll become the column name for each of the columns within that pretty table. So then we're going to ask for a directory to scan. I have a local directory set up here that's right underneath my where the script is running called test. And I'm going to basically go ahead and get the elements, the entries that are in that particular list. I can put my cursor over it. There's only 4 files in that directory that I want to basically try to process. So then, as we've done before, I'm going to get the local path by joining that directory path that I just entered with that to get myself, the path to that particular file. And then I can also get the absolute path. Once I have the local path, I can convert that to an absolute path and get the entire path of where that file is actually stored. Then I'm going to get the extension, and I do that by using the split text method from OSPath, and basically getting the first item, which will be the last part of the file name, in this case, which was .exe. So then what I'm going to do is I'm going to get the file size. And when I get the file size, it's a big number. So I want to kind of format it a little bit. So I'm just going to use this notation to basically use the format function. And this basically creates a string that has a comma at the 1000th position. So now if I look at file size, it'll say 91,329. So based on that, I'm going to try to open that particular absolute path. Remember, that's the path of the first file that we had entered through. We already converted it to an absolute path. And if I try to open it, it's going to basically tell me, yep, I was able to open it. That means it is in fact an image Then I'm going to get the format, I'm going to get the mode, I'm going to get the width, and I'm going to get the height. There's a couple different ways to do that. So it is an image, it's a JPEG, and it's of type RGB. So it's got red, green, blue values. So different from the JPEG format, which is a compressed format. The actual type of the file is still an RGB image. And then what I'm going to do is I'm going to add that information, the status, the path, the file size, the extension, the format, in this case, a JPEG, the width, the height, and the image type, which is RGB, to that row. And then I'm going to repeat the process. So remember, one of the things that typically happens is if you don't add the row while you're in this loop, right, then and you only add it at the end, then you're only going to get the last one. I've seen that several times now. So then it's going to process the next one, and going to go ahead and get the next one that we're going to process here, and it will do that. So now we have, I'm going to set a breakpoint down here because now I've processed, once I've processed all of the files that were in that directory, it's going to come down here, and now I can actually print out the contents of the table because I processed all those files. And I like my stuff aligned to the left, so you can use this property of the table that says table align, and I'm going to align it to the left. And then I'm going to basically go ahead and print the table. So now I have exactly that table that I created before with the image, whether it was an image or not. One of them wasn't. This test bin file was not an image. You notice this one that I had labeled app.exe was in fact an image. Just changed the name of the extension of that file to make it look like an executable, but it was actually an image. And we can kind of see all of those parameters that we were in fact looking for. So that's the first one. I'll post that solution back to week 4 tomorrow. So if you had any issues with this, you can actually run my script and step through it and make sure that you understand that one carefully. Any questions on that one before I go on? And that one was pretty straightforward. We're just using the image open method in order to determine if the file that we're processing is in fact an image, because if it's not, it will give us an exception like it did here for the test.bin. Any questions on that? Okay, I'll move on to the second script that was for A6, in other words, assignment number 6. And in this one, we're actually going to go ahead and try to extract some EXIF data. In other words, some information about the lat long locations where these photographs. Now, again, in JPEGs, not all JPEG files are going to have geolocation information, and it's going to depend on, whether that was enabled on the camera or not, and that kind of thing. So it could be there, it might not be there. So we're going to actually go through and loop through each one of the images, and we're going to get, the date, the time, the model. And then if we happen to get GPS info, then we're going to do some additional things. Basically go get those tags that contain things like the latitude, longitude locations for this particular photo, and whether it was a north reference or south reference or east or west reference, because the way this information is encoded in an EXIF file, it actually is basically information that is providing us with data that is in a different format. It's going to be degrees, minutes, and seconds versus a decimal value. So I provided you guys with a convert function to convert that degrees, minutes, and seconds to to the decimal notation that we typically need when we're trying to post these to a mapping program online or something like that. Most of them require a dotted notation, in other words, an actual decimal number for the latitude and longitude, and not degrees, minutes, seconds with the reference. They're looking for a simpler way to map those. So that's what this script does. So we basically process each one of those images, and then we actually are going to print out a table at the end. So let's go ahead and do that same directory again. let me stop that other script and I'll just run this one for you. And this one basically will provide some simple information. So this is a small directory. So basically it came back and gave me the file name. It gave me the latitude. You notice the decimal notation, not degrees, minutes, and seconds. It comes back and gives me that physical lat and lon value in decimal notation, the timestamp of the image, and the make and model of the camera. So once I had that information from these or other images, then I could go to the map maker program that I have located, and then I could go ahead and map each one of these images that I had. So you notice it has the coordinates of the image, it has the name of the image and where it was located, so you can put your cursor over that. And how I got that was I had created a Excel spreadsheet, actually a CSV file that contained that information. The mapping program requires the lat, lon, the name, the color, and a note if you wanted to. And you have to provide that dotted notation, that decimal notation of the latitude and longitude, and then you can actually upload that to the mapping program, or you could have typed them in one at a time. So in this case, I basically put those in to the mapping program by uploading that Excel spreadsheet, actually a CSV file, a comma separated value file with that data in it. And again, I'll post that solution for you tomorrow as well if you had any issues in doing that. In other words, extracting that EXIF data. Does anybody have any problems? Is there any questions that are related to how? I think I gave you a lot of examples for this and did most of the heavy lifting in converting the latitude, longitude values from the, from the minutes, seconds, from the degrees, minutes, and seconds into the dot. It is a decimal notation, but you still had to basically create this loop to go through each of the files, pretty much like we did in the first example, and then basically calling the functions to get that EXIF data, and then basically using the extract lat lon function, again, that I provided you with in order to get that data from the image. And again, if it had that data in it, in other words, it does require that. The other thing you might ask is that, well, couldn't somebody go in and modify the latitude, longitude data within an image? Absolutely, they could. And then you have to use other information to verify that that information is correct. So it's not, I wouldn't say it's forensically sound, but it's certainly a pretty good indicator where that photograph was taken without the manipulation of the EXIF data within the JPEG. Any questions on either of those kind of assignment reviews? I know we did some of that on Saturday and Monday during the session, just to make sure you had those that kind of down. Any questions? Let me bring up the chat window because I'm not looking at the chat. Okay, I guess there's no questions with that. So let me get into this week's overview, and then I'll show you a couple demonstrations for this week. And then you guys can tackle this week's assignment, which I think is kind of fun. Minimize this. Let me bring back the briefing, and we get to the right one.
Professor, will we have a PDF for this week?
For assignment for week 5, I probably haven't enabled the week yet. Let me go into since the week starts after this lecture. I typically don't. Yeah, the week is not visible yet. And I typically have to enable the quiz and the assignment. So they should be there now. You should be accessible to those. Oh, there are 2 assignments. So now everything should be enabled for you. Thanks for reminding me about that. Everything should be there for you now.
Thank you.
Welcome. So just that was the quick assignment review. Like I said, your map should look like something like this if you actually use that mapping program to do that. So let's talk a little bit about binary files. When we're talking about JPEGs, those are in fact binary files. They're not pure text. They actually have binary data in them. And when we read those in, we can't read them in line by line. We have to kind of read them in byte by byte. Sometimes they can be very large. It could be an image of a drive, or it could be a memory snapshot, or it could be something else that was really large. And the structures tend to either be fixed or dynamic, or in some cases, no structure at all. And based on that, we have to figure out a way to basically extract the data from those binary files. That's what we're going to talk a little bit about tonight. So the first thing we're going to do is basically just open up a file that's a binary file and basically process it by chunks. Okay. And so let me kind of walk through that, that particular script for you so that you can kind of see how that works. And it's pretty simple, but let's go through that script, the one that was in the PowerPoint. So in this particular case, I'm going to basically set a chunk size. In other words, how many bytes of the file do I want to read every time through the loop? Instead of reading like we've done so far, reading the entire file into a variable, we're going to basically read chunks of the file until we're done. So I'm going to show you how to do that. It's important. It's typically how we actually do it. We've been kind of using kind of a shortcut so far, and basically reading the entire contents of the file. And the reason we can do that in Python is because it has access to all of the memory of the system we're running on. So if the files are reasonable size, even maybe 50, 100 megabytes, it'll just read them all into a single variable. But more practically, we typically read those in as chunks. I'm going to read the chunks here 1K at a time. 1024 is 1K. And then I'm going to basically set the chunk count so we know how many chunks that we have. And then I'm going to specify this test file called test.bin that I want to open. So I'm going to open the file, but this time I'm going to open it as RB. So I'm going to read it in as a binary file. And I'm going to give it the name, the object name as binary file. Put my cursor over binary file. It says, oh yeah, it's a binary file called test bin. The open worked because I didn't get an exception. And the first thing I want to be able to do is go ahead and get the file size. We've done this before, so we can use the OS module, the path.getSize method. We'll get the file of test file that we're trying to run right now. I can look at file size. So, okay, it's 174,308. I'm going to read it 1,000 bytes at a time, 1024 bytes at a time, 1K at a time. I can print that out. I can print a little heading here because I want to print out the chunks. So now I'm going to create a while loop that runs forever. It's called while true. Basically, it's going to run until we hit a break. Otherwise, this is going to continue to run. So what I'm going to do is now I'm going to use the read method we've used before, but this time I'm going to pass the read method a value, in this case 1024. So I'm going to read 1024 at a time. So the next thing I do is I say if chunk. So in other words, if I didn't read anything, in other words, I was done, I've exhausted all of the data in the file, I'm not going to get true. I'm going to get false back from if chunk, because chunk would have no data in it. So thus it would be false. So in this case, if I say if chunk, it's true, it means there's some data in the file. So what I'm going to do is I'm going to print out, what chunk we're on, and then I'm going to print out hexify of the chunk, and I'm going to print out just the first 32 bytes of the chunk. I'm not going to print out the whole 1,000, just the first 32. So that chunk that we read in, I can put my cursor over it, and it's just a bunch of data, right, in this particular example. And so now I'm going to actually print that out. So there's the hexlified data that was the first 1,000 bytes. I can increase my chunk count. I can do that again. And now we have chunk 2. So now we're basically seeing each of those chunks that we read for that file. And this might not even have been a binary file, but it doesn't matter. So if I say go and I hit to script end here, I'm just going to say go. And we read 171 different chunks. So if you multiply 171 times 1024, it's going to be greater than the file size. that we had, because it wasn't on an even boundary. So we had to read 171 chunks to read in 171 chunks of at least 1,024 bytes each in order to read in that entire file and then print out the first 32 bytes of each chunk. So that's how you actually go ahead and can basically run through a binary file chunk by chunk. And in this case, I just did a simple thing, which was to print out the first 32 bytes of the chunks. You can do a lot more. We'll do that more in this week's assignment. So that's just a really simple script that you now have that you can play around with and use in order to move that forward. So any questions on the read binary? So it's just a little bit different than what we've done before. We don't read the entire file into a single variable. We read the file a chunk at a time, and you can pick whatever chunk size you want. It doesn't have to be 1,024. It could have been something else. So if I came back here and I said, oh, I want to read instead of 1,024, I want to read 4096, which is 4K. And if I save that change and I just rerun the script, I'm going to go ahead and restart the script. In this case, it's going to run through that script. No, it's got to say go. And I hit a breakpoint set. Say go again. And this time it only printed out 43 chunks, because each chunk in this particular case was 4,096 bytes in length for 4K. And therefore we needed less chunks. Just kind of give you an idea. You can come in here and play around with it yourself and just kind of make sure that you kind of have a feel for how this logic works and how the while true works and how you're reading each one of those as you go through that file. Any questions on that one? Okay, cool. So the next thing is when we're actually processing binary files, or like I said before, even text files, one of the things is we want to search. Now we've done some searching already when we're searching for specific strings, right? Or keywords or phrases and those kinds of things. We kind of know how to do that, and we can use Python to basically help us, do those kinds of searches. And even count the number of occurrences of a particular keyword or phrase. And we've done that before. The difference between regular expressions and, let's say, specific keyword or phrases is we're searching for a pattern and not searching for a specific keyword. In other words, we're basically looking for a certain structure that represents, in fact, a pattern. This is something we use a lot in many things that we do when we're actually performing searches. So for example, if I want to search and find all of the email addresses within a particular binary file, I can't possibly know what all those email addresses were, but I do know how they're structured. So I can then define a pattern that will help us define and collect all of the email addresses based on structure or based on pattern, not based on value, in order to be able to do that. There's a couple of really simple ones. I'll show you right now. This first one, we can also use regular expressions in order to be able to do some simple substitutions. Let's, for example, I have this binary file and I'm only interested in, let's say, A to Z in value, and I'm not interested in all this other garbage that might be in there. So I can substitute that out using a regular expression as well. So if I wanted to take that script that's in your PowerPoint, I can basically create a string. I'm bringing in the regular expression library. Again, it's a core library within Python. It's part of the standard library that you can use. And I'm going to go ahead and stop this other script first. And let's actually walk through this one. This is a really simple script that kind of points out a really neat function that you'll use a lot within this. First thing I'm going to do is I'm going to import the regular expression library, and then I'm going to create a string. And the string has some words in it, but it has a bunch of special characters in it as well that I kind of want to get rid of. So I can use the regular expression library, and I can use the function sub, in other words, substitute. And if it's not A to Z or A to Z, I'm going to replace it with a space. So that's how you read this, as the first part of this is what I'm looking for. And normally you'd be looking for something specific, but in this case, if it's not, it's what the up arrow does. It says if it's not capital A to Z or lowercase a to Z, then substitute that with a space. You could put anything you wanted in here. I chose a space, so we would basically space out all of those other characters in here. So once I do that, I've created now a new variable called text, which has eliminated all of those other characters. So I can print those out. That was the original string. This is the string that was created by substituting all of those special characters out and making them into spaces. And then I could basically use the split method on both the original string and the one that I've substituted. And then I can print out word complex, which is just a mess, or I can print out word simple. And now I get the 3 words that I was interested in within that particular string. And obviously you could do that for a whole file if you read the whole file in, but the substitution function here really kind of works very nicely in order to do that. So for example, if I wanted to do something different, let's say I wanted to include space in the allowable character. So if it's not A to Z or A to Z or space, and then basically I want to replace it with nothing. If I change the script to do that, you'll kind of see the difference here. So in this case, that's the original, that's the substituted. I can print S and I can print this, and now I basically eliminated all of the white spaces as well. So any of those that were there are no longer with us. And now I can print those out and I get the same result. I'll put this back the way it was. So that's the simplest regular expression I can show you. I'm going to show you a more complicated one in a second when I actually can find emails in, and you're going to be using this week during your assignment to explore that a little bit further. So that's just a simple way to basically substitute things that are in a string to get only what you're looking for. You might be looking for commas and other punctuation, and then you want to eliminate everything else. You can do that with this simple substitution regular expression. So the next thing I might want to do is I might want to be able to extract and find email addresses within a string, right? And I want to do that based on the structure of the email. In other words, a pattern that will match any email based on structure or based on pattern. So this is what the pattern of a regular expression to be able to find an email address. So this is what would be the first part of it. Then there's going to be an at, right? It's going to be somebody's name at, then it's going to be a bunch of other stuff. Then it's going to have, dot, and then it's going to have, some characters after that, something .com, for example. And then once I have that pattern compiled, and you're not going to have to create the patterns, all the patterns we're going to use this week, I've already provided for you. And then I can use the pattern to find all that match that pattern in, let's say, the string S. And I'm going to show you how that works. Let's go back to the, let's go back to Python here for a second, and I'll bring in the, where'd it go? Yeah, here we go. So this is the regular expression email for how you would process a file. In this case, just a string that I've actually brought in. Make sure I'm on the right one. So what I'm going to do is I'm going to bring in a couple libraries here. Bin ASCII and Pretty Table and a bunch of stuff that I might want to use. I'm going to basically set my chunk size, and now I'm going to create my email pattern. So the way you use the regular expression, once you have an email pattern that you want, a pattern that you want to basically compile, you can compile that pattern so then you can use it. So in this case, I'm going to compile that email pattern. You notice that I basically preface this with B because I'm going to read in from a binary file. So I have to make sure that the pattern that I'm compiling is a byte string, not a simple string. So that's going to determine what you're going to do. And this week, you're going to be using ones that are all byte strings. So I'm going to create a dictionary called email dictionary. And what I want to do is I want to process this raw memory file. I'm going to read that binary in, and I'm going to read it in chunks, right? Just like we did in the previous example. So every chunk, instead of just printing the values of the chunk, I'm going to check to see if and obtain all of the emails that occurred in that particular chunk. Okay, so let's actually step through this. So I'm going to get a chunk. I'm going to basically now use the pattern to find all of the emails that occurred in that chunk. Okay, because I'm calling find all on chunk. In this case, it's going to see if there were any emails in there. And I don't think there's any emails in the first chunk. So in the first one chunk that we had, it didn't find any matching patterns. That's fine. Let's go to the next chunk. And did it find any there? No. So let's set a breakpoint down here and we find our first chunk that actually contains an email. Okay, so we got one. So in this particular case, we found something that looks like an email that was in that particular chunk. So there could be multiples in that particular chunk. And so now what I'm going to do is something we've done before. I'm going to see if that particular email exists in my dictionary, which it doesn't yet, right? So I'm going to put it in the dictionary and I'm going to set its count to 1. In other words, how many times does it occur? We've seen this logic before. And that was the only one that was in that particular chunk. So I can say go again. And now I've got another one and I can see if that one exists in the dictionary, and it does. It was the same one. So that same email existed in this next chunk, which is fine. It currently had a value, key value pair. The key was the email address. The value was how many times it occurred. So I'm going to increase the number of times it occurred, and I'm going to write that back to my dictionary. We're going to do this for every chunk, and every time we find a matching email pattern, we're going to basically update that. So then I'm going to set a breakpoint down here. So I'm going to process all my chunks within this memory.raw file. I can't remember how big that file was. Apparently it wasn't that big. So now I'm going to create my email table. And in this case, I'm going to create a table, and it's going to have the number of occurrences and then the email address. So now what I'm going to do is that email dictionary that I created has a whole bunch of values in it. It has all of the pattern matched emails along with the number of times as the value that it occurred. So this is kind of cool, right? So now I can basically add all of those to my dictionary. When I'm all done adding those to my dictionary, I can now sort those out because I can use the alignment, and now I can actually sort my email table that I created by occurrences in reverse order. What that's going to do for me is basically show me the email addresses that occurred most often in that particular mem.raw file that I just processed. And so now I can actually come back here and I can see all the emails that we just processed out of that binary file and find which ones occurred the most and how many occurrences of each ones that we found. So again, we weren't searching for a specific email. We're searching for a pattern that matches the pattern of an email. Okay. So that's really valuable to us when we're actually trying to extract information from, a binary file. And I want to pull out things like email addresses, URLs, words, etc. What you're going to do this week. And this is a good model for you to use. And I've provided you with this particular script in D2L, so you can use this as kind of a starter script for you. Let me jump back to the briefing real quick, unless there are any questions on that. What I was doing in that particular script to kind of show you the example of how to use an actual regular expression pattern, in this particular case, the pattern of an email, in order to be able to extract patterns that match that email. And there's many patterns out there. There's patterns for phone numbers and zip codes. And remember, phone numbers for all other countries are a different format than ours. And there's literally thousands of different regular expressions that you can use in order to pull different information from a file. Any questions?
Yes, I had a question. When writing the script, if we were using this in the real world, regardless of what we were searching for and the chunk size, what happens if your chunk breaks up that piece of information that you're looking for? Is there a way to account for it so that you?
Yeah, there is. And that's one of the things you're going to be working on this week to see how you actually go back and do that. And I will show you that. I'll give you some hints along the way on how to actually pick up any of those overlapping data that happens to fall on the chunk boundary. It's a really good question. It's something that you'd have to do if you're reading chunks in and not the entire file. So what you would do is the next time you provide it, I'll give you a little hint. If I read in the chunk, right? And what if I save the last, I don't know, 32 bytes or something of this chunk and then prepend it to the chunk that I read next time? Then it'll get those first 32 bytes from the last one plus the new chunk, and then we'll basically process that. So there's a way to basically save those last whatever number of bytes that you want to basically be your overlap, and then prepend them to the new chunk that you're reading. Make sense? So that's kind of the trick in general. It's not that complicated to do, but we can kind of go over that as you guys start to work on that your own. We can go over that on Saturday. It's a really good question. I could give you an example of that without giving away the solution to this week's assignment. Make sense?
Yes, thank you.
You're welcome. Good question. Okay. Anything else? Okay. I think I'm almost done. So again, I went through that search. So your assignment this week, let me go back to the to D2L real quick. And you're going to do 2 assignments this week. And in the first one, you're going to process this large memory dump that I'm providing you with, and you're going to search for email patterns and URL patterns, and you're going to basically provide those results, kind of like just what I just did, but you're going to do it for multiple patterns to basically pull out all the email addresses and all the URLs, and I'm giving you the patterns. So you don't have to create the regular expressions. I'm giving those to you so you can use them. So that's the first assignment. The second assignment is you're going to do the same thing, and I'm giving you the regular expression as well, but this time you're going to actually extract all of the possible words. Now, these are not all necessarily words, but they're strings that are continuous that you have that are of at least 5 to 15 characters in length, and it's going to pull all of those out for you. And you're going to basically, again, pull out all of those, let's say in double quotes, words, really strings that you're going to pull out so that you can look at those, which also could be extremely useful when you're actually processing data to see what that's about. In other words, kind of give you an idea of the kind of information that is in that particular file, whatever you're processing. And again, you can rank them by the number of occurrences, and that will give you information. So there's 2 assignments. They're very similar. They're both going to be processing the regular expressions. The first one, you're going to process the email and URL patterns and provide those results. And the second one, you're going to extract all of the quote words that were in that particular assignment. Let me see. Oh man, I have too many things open and whatever. I apologize. I didn't need to click that button. Yeah, I know. Okay. So that's what you're going to do this week. And then next week, make sure if you haven't done this yet, make sure that you are working and are able to access and work with Cyberopolis, specifically the VLE, because next week you're going to need to use the virtual learning environment and access Cyberopolis. So just make sure you can log into the VLE and everything works there for you, because next week we're going to be actually scraping information from websites within Cyberopolis. So we're going to basically scrape information from those websites, which obviously can be really useful in the wild, but we'll do it in a more controlled environment within in scraping websites within Cyberopolis to collect data from those. And you can kind of see that, hey, what we're doing this week to extract words or extract emails and URLs, we could do that to a website. once we gather the data from the website. We're going to show you how to do that next week, and doing it again within the VLE and accessing websites that are currently running within Cyberopolis. So that's what we'll be doing next week. So it's a pretty straightforward week and you're going to get hands dirty a little bit doing this. The one thing I'll warn you about is that the file that I've given you to process is fairly large. So don't get impatient when you're actually running your script against this larger file. So one of the things you want to do is perfect your script, each of your scripts on smaller files, and make sure that you know it's working, and then run it against the larger file, because the larger file is going to take a while, either on your local machine or within the VLE. And I've seen it take as long as 30 minutes. So remember that when you get into that, and don't get freaked out if you don't think it's running. It actually is. It's just going to take some time to process that larger file. I think it's like 128 megabytes or something like that. So it's going to take a little while to actually go through that and extract all of those emails and URLs and words from that particular file. So just keep that in mind, and don't get discouraged if it seems to be taking a long time. But the best strategy is to make sure that you test your scripts against a smaller file in order to be able to make sure everything is working correctly, and then apply it to the larger file. Okay. Any questions for this week? And if not, I'm going to give you like 15 minutes of your life back. Elizabeth, I think you're here. Did you have any questions that were either related to last week's assignment or anything that I should cover?
I didn't receive too many questions from last week. The only thing is, for these binary files, you won't be able to open them like a normal file, like a text file, or like a JPEG image, or like a PDF. These files, it's just when you're processing them, they'll just be used in the Python script. So when you try to open it, it's not gonna open on your end.
Right. So you're absolutely right. When you copy those over to the VLE and use them there, or even on your local machine, you have to open them this way. We have to process them, within the loop that, we're running here within Python. It's a file. It's just not defined as anything that the operating system knows about. Therefore, it can't open it and display it for you. I'm glad you brought that up, because we do run into that every semester. People saying, hey, this file doesn't work. It's not supposed to work. It's just binary data. It doesn't have any associated application that can open it and display it. That's kind of the whole point of why we write scripts, in order to be able to do that. Great. I'm glad you brought that up, Elizabeth. Always an issue that we run into. Any other questions before I let you guys go tonight? And again, remember, we do have a Python tutoring session on Saturday morning, and then the office hours on Monday as normal. And obviously Monday is Valentine's Day, so maybe there won't be too many showing up on Monday. So anyway, any final questions? I'll give you one last, going once, going twice, going 3 times.
I have a question about the memory dumps. I've just downloaded it and it's a few K. So I'm not sure where the large file is.
It should be in the
Test bin is 171K, and mem dump is same size.
I wonder why that is. Glad you brought that up. I will make sure that I post the larger file for you.
Thank you very much.
Maybe I did that because we had so much trouble with the larger file. So maybe it's a strategy, but I will post the larger one for you. I'm glad you brought that up. Thanks.
Thank you.
We'll process those. Thank you. All right. If that's all, have a great rest of the week and weekend, and Super Bowl Sunday if you're into such things. And we'll hopefully see you guys on Saturday and on Monday, and next Wednesday we'll be scraping websites. Have a good night, everybody.
Thanks a lot. Bye for now.
Bye.
Thank you. Good night.